dynamometer, it consists of two wooden blocks. It consists of two wooden blocks. These are the two wooden blocks which I have already specified. Okay, so I have shown all the points to you people. So around the pulley fixed to the shaft, that pulley is fixed to the shaft of an engine whose power is required to be measured. Now pulley which is rotating, that pulley power we people are interested to measure. So blocks are clamped by a mean of a bolt and nut. That bolt and nuts I have shown that has been tightly fitted. So helical spring at the right side, which you have seen, I have shown you at the right side uh, that helical spring is also mounted. So that will provide, this spring is going to provide between the nut and the upper block nearby that particular lever to adjust the pressure on the pulley. Because what happens, we are supposed to apply brake. So force is to be provided. So spring is providing the bridging the gap between the nut and upper block of the wooden to adjust the pressure on the pulley. So when they are coming across that rotating pulley and the wooden block, what is going to happen? Retarding force is generated to stop that particular pulley. So the upper block has a long lever which I have shown you, lever attached to it and carries a weight. Now this weight which I have specified at the end. So counterweight and that particular weight, they are placed so as to manage or balance the mean. So at the other end of the lever, that balances the brake when unloaded. When unloaded means when we are not, when it is freely moving. So in order to limit the motion of the lever, now what is happening if you don't use a counterweight and we are applying? So force will be exerted at one side. Now suppose here this is the lever actually. This is the lever. I am having it. This is the straight lever. If suppose I have not applied a weight at this moment and I have applied a weight at this moment, this will move in the upward direction. So when it is unloaded, it is supposed to manage the lever. So in order to limit the motion of the lever in upward and downward direction, two stops provide. Okay, two stops are provided. So that I have already shown to you people. So when brake is to be operated, means to stop the long end of the lever. Which one is the long end? Long end of the lever. If you see the long end, this is nothing but the long end. Okay, the long end of the lever is loaded with a suitable weight. It is loaded with a suitable weight and nuts are tightened until the engine shaft runs at a constant speed. That nut will be tightened in such a manner that the engine shaft or the pulley will rotate in a constant speed and the lever is in a horizontal position. No doubt it is in the horizontal, it is not in the vertical direction. So under this particular condition, the movement due to the weight must be balanced. So moment of friction resistance between the block and the pulley. So that is going to provide the balance. Now, how we people are going to measure the torque with reference to this one? Because we are applying a brake on it. So what are the contents? We have seen weight. We are having a lever length, that is the horizontal distance of the weight from the center of the pulley in terms of meter, radius and speed of the shaft. So the moment of the friction resistance or a torque of the shaft is given as tau is equal to weight which has been applied, that is applying a brake. weight. If you increase the weight, definitely it will create an obstacle. It will create an obstacle. Weight into length. Weight into length. However, you are applying a brake. You are applying a brake. So your brake power is given as T into 2 pi n divided by 60, which we have seen previously for power measurement. But what is T? T is nothing but it is W into L, which I have represented over here and also over here. Okay, W into L into similar that one. That is 2 pi N divided by 60. Actually, this 60 have been shifted to this one. Here it is 60. Okay, so the power which you are interested to measure, brake power, is given by this equation. It is given by this particular equation. You can easily measure the power using this formula. So you people are having the formula with you to measure the power. So you can easily solve the problem to determine the power or retarding force that can be used. Okay, so there are some merits, some demerits. So when we people are driving a torque on the shaft, it is not uniform for this particular foaming brake. So this dynamometer is subjected to a servo oscillations. And what is oscillations? Whatever output you people are getting, they are in this particular form. These are oscillations. They are not not smooth output you people are getting. Okay, and its application is to measure power or a torque developed by a power source such as a engine or electric motor. Second one is the rope uh, brake dynamometer. I will give one example. Suppose I am having a